We are about to start Chapter 7, and Chapter 7 will involve lots of factoring, which is what you just did in Chapter 6. So I'm hoping that you did very well on your test for Chapter 6, and so if you didn't, you will want to do test corrections to make sure that you understand this is not going away. The other thing that we're going to see here are rational functions. And rational is just another word for fractions. So if you don't like those, then this is going to be a rough chapter. So just know up front, you will use your factoring that you learned in Chapter 6, and we will look at fractions. That's what we're talking about, rational. Ratio is the root word there. When we're looking at fractions and factoring, the first thing we're going to look at is a different way of writing this, and we didn't do this in 307. But we will start seeing things written in function notation. So you just want to keep in mind that function notation looks like this: f of x, g of x, h of x, and then you'll have more than likely an equation following it. I mean, it is an equation. So if you'll think back to what you learned about graphing, then the f of x is the y. And so what we're looking at here, if we had the little t-chart, then you would have the f of x here. It's going to be the answer that goes here. Everything here in the x column is called the domain. And everything here, I'm running out of space there, let me erase that, range. So we'll see lots of stuff about function notation. F of x, it just is another way to state y. Here we'll have, think about the t-chart. Here's the x, the domain, here's the y, that's the range. We'll see a little bit more about this in a minute. When we're looking at, remember I mentioned that we will be talking about fractions, and we want to remember that if I have 0 in the denominator of a fraction, this does not equal 0. It is undefined, doesn't have a definition. So we want to keep this in mind, that the denominator cannot equal 0. So when we're working with these rational functions, remember that they're going to be in the form of fractions, and this denominator cannot equal 0. So what we want to find out first is, what can x not equal for this equation? So we're going to take the denominator and set it not equal to 0, and then solve it. Divide by 2, x cannot equal 0. So 2 times 0 would give you 0. So it can't be 0. 2 times 1 would give you 2. So it could be anything but that 0. So what we did here is we're going to set the denominator not equal to 0, and solve. Our answer form is going to be a little bit different. Domain is, and then we'll have this set notation to open up. Domain is x such that x is a real number, but x does not equal 0. For our next problem, we have c of x equals x plus 4 over x squared minus 16. Take the denominator, set it not equal to 0. Well, remember what I said about the factoring? Here we're going to have to factor to be able to find out what this number or numbers might be. Hopefully you'll notice I've got two terms, a minus in the middle, and a double. X times x, 4 times 4. So this is the difference of two squares. So we'll have x and 4 in each set of parentheses. One will be positive, one will be minus. Then we want to take these are our factors, and we want to set those not equal to 0. Not equal to 0. So we've got two answers here. So again, it'll be a statement that says x such that x is a real number and x does not equal, and you'll list both of these, and it will be in set notation. What you'll have to do in course or my math lab is come up with these numbers. They'll give you a box. They will have all the other words here and have a box, and you want to be sure and separate it with a comma. Oh, sorry about that. Clear this up a little bit. Okay. Something else we need to remember about fractions. When I have the negative in front of the fraction, if I rewrite this, I can write it with the negative in the numerator, or I could write it with the negative in the denominator. All of these are equal. We will be looking at things that are a little bit more complicated. And very often, if you will keep in mind something that's easier to remember that you can relate it to, then it will help. So this is why I start with a simple fraction and talk about the negative. It can go on the top and it can go on the bottom. We're going to do the same thing here. We're going to put the negative at the top, but then we're going to apply that negative. So we want to rewrite this. The negative is going to come to the top, and it's applied to the x minus 3, and then our denominator stays the same. If I go ahead and distribute that, then this will also be equal to negative x plus 3 over x plus 4. if I take the negative and apply it to the bottom, like we did up here, and then if I distribute it like I did here, then I get a fourth answer. So what I know about all of these is that they are equal to this one. These are all equal to each other. You will need to keep this in mind. It may be something that you have to apply to be able to solve something in the future. Something else we want to remember about fractions: when the number on top and the number on the bottom are the same, they equal 1. So if I have x plus 2 over x plus 2, that equals 1. It gets a little complicated when you start putting in the negatives. If I have x minus 2 and 2 minus x, these look very similar. We've got x's, we have 2's, and we have minuses. But if I took and rearranged this so that it was in the same order as this one, so I could see if they matched like these two do, then I have to remember that the sign that's in front of that 2 stays with it, and what's in front of that x stays with it also. And when we look at this, these do not match exactly. But if I factor out a negative 1, negative 1 times 2 is the negative 2 that we started with. Negative 1 times negative x is the positive x that we started with. When I take out that negative 1, then see, I can rearrange that easily, and I get the same thing I have on the bottom, and those cancel out. They become 1. So here, whereas this one was equal to 1, this one is going to be equal to negative 1. So you just want to keep that in mind as you're going through and solving these problems. All right, let's go ahead, and that was just an introduction to get us started with what we need to do today. We want to simplify. We're not solving. You can only solve equations. The process to do this is we need to factor first. The other thing we want to remember is to reduce fractions. We cancel factors. And we want to remember here, what are factors? Numbers that are multiplied. So another very quick little review before we get started. Let's say if we have 12 over 18 and I need to reduce that fraction. You probably already know that we can divide this by 6 and get our reduced fraction. But if I want to write it as factors, which is what we're going to do in this section, 12 is 2 times 2 times 3, 4 times 3. 18 is 2 times 9, which would be 2 times 3 times 3. These numbers are being multiplied. They are factors. And so what I can do here is when I have 2 over 2, that becomes 1. 3 over 3, that becomes 1. And my answer is going to be what's left. Now, like I mentioned, most of you would recognize that you could take and divide both of these by 6 and get your 2/3. That's that 2 times that 3 is where we get the 6. But what I need you to see here is that to reduce fractions, we cancel factors. Not numbers that are added or subtracted, but numbers that are multiplied. You want to keep that in mind for what we're going to do. So when you look at this problem, we can't say that x over x cancels out and becomes 1, because here the x's are not factors. This is a positive, it's being added. This one's being subtracted. What we need to do is take what's on the bottom in our denominator and let's factor it, and then we'll be able to cancel some things out. See, this x plus 9 altogether is 1 factor. At the bottom, we're factoring a trinomial. I know that the first part will be x and x. I've got a minus at the end, so that means one of these will be minus, one will be positive. When I do subtract, I get 1 in the middle. So 10 times 9 gives me the negative 90, and when I combine that, I get negative 1. And then look, this, it doesn't look like a simple factor because there's 2 terms, but it's in these parentheses, which makes it multiplication, which is factors. This x plus 9 matches this x plus 9 perfectly, so we can cancel that out. Now when we cancel this, we say cancel, but really what we're saying is they become 1. So my answer here will be 1 over x minus 10. Okay, let's look at another one. You'll need to think back to chapter 6. Here we have the sum of 2 cubes. Sum of 2 cubes. Remember, we had basically a formula for that. A plus b, a squared minus a times b plus b squared. It helps me to come over and say x cubed is x times x times x. 216 is 6 times 6 times 6. Then I know that this is A and this is B. And I can fill it into this formula that I have here. So open up my set of parentheses, and A is x and B is 6. Open the other set. A squared would be x squared minus A times B would be 6 times x plus B squared, well, B is 6 and 6 times 6 is 36. So here we have factored the sum of 2 cubes. Going to go ahead and write down the denominator that I have. Notice that these two are exactly the same, so they cross out and become 1. And I'm left with x squared minus 6x plus 36 as my simplified form of this rational function. Our next problem has 4 terms in the numerator and the denominator. We will use grouping. We're going to factor by grouping because we have these 4 terms. So we want to remember, we're going to group these 2, circle, group those 2. So 5xy plus 7x have an x in common, and what's left is 5y plus 7. Bring down the minus. 5y minus 7 appear to have nothing in common, but they actually have a negative 1. 5y, and then this becomes positive because that negative times the positive gives us the negative that we started with. Then we want to look at the denominator. Circle, circle, or sorry, underline, underline, circle. The first one have an x in common. Then we have 6y plus 1. Bring down the negative. And again, they appear to have nothing in common, but they have a negative 1. 6y plus 1. Make sure you remember this and this must match for this to work. So we have x minus 1 times 5y plus 7 over x minus 1 times 6y plus 1. Cross those out because they are the same and write our answer. 5y plus 7 over 6y plus 1. For our next problem, when we look at these, we have 2 terms and a minus in the middle, but we also have a minus at the front. So this is not the difference of 2 squares. These 2 have nothing in common. These 2, they have a GCF in common. So we're going to take out the negative 2. Negative 2 times x gives us negative 2x, and negative 2 times a positive y gives me that negative 2y. All of this is over x plus y. These 2 cancel, so I'm left with the negative 2 as my answer. I want to give you some problems to practice with. I try to do this with most of our lessons. If you feel confident and are ready to go ahead and tackle your homework, you can try that. But I really encourage you to do the practice problems while you're watching the video, and I think that will help you with your homework. If you have questions, email me. Okay? Alright, so let's go ahead and I'm going to write some problems for you to do, some practice problems, and then what you're going to want to do is pause the video, so this is going to be our practice. If we were in a face-to-face class, I would call this for participation. And then I'd have some students go to the board and share their answers. Okay, so we have 3 problems here. I want you to write those down and then pause the video, do the practice, and then start the video back up. And when you have, you'll magically have the answers. Voila! There are your answers. Here, we factored out a GCF. On this one, we had to do that long 4 or 5 step process where we start by multiplying the first and the last terms, and we end up factoring by grouping. Here we had GCFs and the difference of 2 squares. Alrighty, so good luck. If you have any questions, then you want to be sure and email me.